8B. This is the fifth episode on this exercise. The topic of the exercise is stationary points. The main topic is further differentiation. This is the course book of the Pure Mathematics 1 that belongs from the AS and A levels mathematics 9709. This is Cambridge A levels, and this course book is related with its paper 1. We are working on the exercise 8B, and this is our fifth episode. And in this episode, we are going to we will start our work from the question number 8 of this exercise. So let's start. In the question number 10, he says, the curve y equals to x cube plus ax square plus b. So here we have ax square. So this is basically ax square plus b has a stationary point at the 4 comma minus 27. Find the value of the a and the value of the b. This is the a part of this thing. Okay, so we have to find out the value of the a and the value of the b. The method is very simple. First of all, I can put this point in this equation. So you see the y is minus 27, and that is equals to the 4 and its cube plus a into 4 and its square plus b. So what I did, because that point is on that curve, so what I will do, I will put the x and the y values. I will substitute those values into the original equation, and in a and b I will get one equation in a and b. Okay, so I need a calculator. Okay, so here we have the calculator. So you will have minus 27. Here you will have minus 27 equals to, this is 64 plus 16a plus b. So this is how we got it. And minus 27 minus 64, that will be equal to minus 91. So you will have 16a plus b is equals to minus 91. So this is my first equation in the a and b. Okay. Now I will find another equation in a and b. He said that this is a stationary point. You know, on the stationary point, the dy by the dx value will be 0. The dy by the dx value will be 0. So I will differentiate that equation. The y is given to me, so y is equals to x cube plus ax square plus b. So I know this equation, y is equals to x cube plus ax square plus b. So I will find its derivative. So my dy by the dx will be equals to 3x square plus 2ax plus 0. So dy by the dx will be equals to 3x square plus 2ax. Okay, because b is a constant number, so its derivative will be 0. He said that the stationary point is at 4. So at x equals to 4, the dy by the dx should be equal to 0, because this is the stationary point's coordinates. Okay, 4 comma minus 27. So at x equal to 0, the dy by dx must be 0. So I will make this 0, 3 into the 4 and its square plus 2 into the a into the 4, and that will be equals to 0. Okay. So in the place of x, I have put 4, and I have made the expression of the dy by dx equals to 0. So this 16 3 is 48. So plus 8a is equal to 0. So 8a is equals to minus 48. So a will be equal to minus 48 divided by the 8, and the a will be equals to minus 6. So you see, we got the value of the a. We wanted to find out the value of the a and the b. Now I will put this a value. I will substitute this a value into this equation, and from there I can find the value of the b as well. 16 into the minus 6 plus b is equal to minus 91. So the b will be equal to minus 91, and it will be plus 6, 6, 1, the 6 is 96. So the b will be equal to 5. Now I got the value of the b, that is 5. Now you can see we have solved them simultaneously, and we have found the value of the a and the value of the b. I'm checking the answer. I'm reading this answer from the book, sir. The a value will be minus 6 and the b value will be 5. Our answers are right. So this was the a part of this question number 10 from the exercise 8b. This is the 5th episode on this exercise. He says then in the b part, determine the nature of the stationary point at the 4 comma minus 27. So we have to find out the nature of the stationary point. You see, I know the derivative dy by the dx is equals to this is 3x square plus 2ax. So dy by the dx. I know the value of the a. That value is how much is that value? Minus 6. So into the x. So dy by the dx will become 3x square minus 12x. So you see, I have put in the expression of the dy by the dx, we have the a there. So I have put the value of the a there. So now the expression for the dy by the dx is 3x square minus 12x. Now I am going to find the second derivative of this thing. Okay. So the second derivative will be d square y by the dx square, and that will be equal to the 6x minus 12. So I want to find out the nature of this point, and it's here. The value of the x is 4. If I want to find out whether this is a maximum point or a minimum point, what I will do, I will substitute x with the 4 in the expression of the second derivative. So what I will do, I will substitute that value. So d square y by the dx square will be equals to 6 at x is equals to 4. So 6 into the 4 minus 12. So the d square y by the dx square will be equals to 6 for the 24 minus 12. That will be equals to 12, which is a positive number. So it means that the 4 comma minus 27 is positive. So this will be the minimum point. So that means at 4 comma minus 27, it will be our minimum point. At 4 comma, let me check the answer, sir. This will be part is the minimum point, sir. And we have also found that this will be the minimum point. I hope you understand this. This was the question number 10, and it's B part. So here I worked on the question number 10, and it's the B part. So this is my B part. Then he said we have C part also on in question number 10. He says find the coordinates of the other stationary point on the curve and determine the nature of this stationary point. Okay, now I have to find out the other stationary point. So you know we had that dy. This is the C part. Now I'm going to work on it. C part, and he says find the other. So the dy by the dx is equals to, it is 3x square plus 2ax. So what I will do, I will put the value of the a here. So it will be 3x square plus 2 into the a value is how much? A value is minus 6. So it will be minus 6 into the x. So my dy by the dx will be equals to 3x square minus 12x. Because I want to find out the other stationary point. So at the stationary point, at the stationary point, the dy by the dx will be equal to 0. So let's make this 3x square minus 12x equal to 0. So take 3x common. So you will have x minus 4 equal to 0. the one value will be x equal to 0, the other value will be 4. This point we already know, so this is my other point. If I want to find out the coordinates of this point, I will put this in the original equation. Y is equals to, and it will be 0 cube plus minus 6 into 0 and its square, and plus b value is 5, and so the coordinates of this point will be 5. So the other stationary point, its coordinates will be 0 comma 5. So these are the coordinates of the other stationary point. Their first question, the C part, is find the coordinates of the other stationary point on the curve and determine the nature of this stationary point. 0 comma 5 is the right answer, sir. Now we have to find the nature. So to find the nature, we need to find out the expression for the second derivative. We already know the expression for the second derivative, and the expression is d square y by the dx square is equals to, we have already found this, that is 6x minus 12. So at x equals to 0, so you will have 6 into, so my d square y by the dx square will be equal to 6 into the 0 minus 12, which will be minus 12, which is a negative number. So I think that the 0 comma 5, because it's negative, the value of the second derivative is negative, so it is going to be a maximum point. So this is how we will do the C point. You can see the C point is showing up in front of you. Okay, then here we have the D part of this question. In the D part of the question number 10 of the exercise 8B from the course book of the Pure Mathematics 1, its D part is find the coordinates of the point on the curve where the gradient is minimum and state the value of the minimum gradient. Okay, the gradient is represented by the dy by the dx. So this is the d part, dy by the dx, that represents the gradient. Its formula is 3x square and plus and 2 into a is minus 6 into the x. So this is 3x square and it will be minus 12x. Okay, so dy by the dx, find the coordinates of the point on the curve where the gradient is minimum. Okay, it's this represents the gradient of the curve. This is basically it's a happy face. So this is this like this, and I can find out this point. I can find out that here the gradient will be the minimum. Okay, so the gradient, the gradient is represented with this. The gradient is dy by dx is represented with the 3x square minus 12x. You can take the 3 common, so you will have x square minus 4x. I'm going to apply the the completing the square. So it will be 3 into the x square minus, in your rough work, 4x divided by the 2x, you will get 2. So add the square of the 2 here, subtract the square of the 2 here. I'm doing completing the square. So this will be equals to x minus 2 whole square, and this will be minus 4. So this will be 3 bracket x minus 2 whole square, and it will be minus 12. So the turning point of this graph will be will be at the you change this sign to, you keep this sign, minus 12. So this is the turning point. So the minimum gradient will be minus 12 and it will be at x equals to 2. So the minimum gradient will be at x equals 2. So the x is equals to 2. And what will happen if you want to find out the the y coordinate, you can put this x equals to 2. At x equals to 2, the gradient will be minimum. So I can put it here. Let me check, sir. Uh, Question number 2. Okay. So I will put this in the original equation. Y will be equals to x cube, that is 2, and its cube. Then you have plus a, which is minus 6, and then you have 2 and its square, and then you have plus b, which is plus 5. Okay, so the y will be equal to 8 minus 4, 4 is 24 plus 5, so that will be equal to minus 11. So the coordinate of that point will be 2 comma minus 11, and the minimum gradient is equals to minus 12. So the minimum gradient will be on the curve at the point 2 comma minus 11, and the minimum gradient will be minus 12. It's a huge question, sir. And let me check, sir. The D answer is 2 comma minus 11, and the gradient will be minus 12. So this is how you will do the question number 10. I hope, because we have put this new board, and this is the first day I'm working on this board, and because this is a little bigger board, so you can see this huge question we have done on one go, and I hope you understand this question. So this is how we have done the question number 10. So let's go to the next question. The next question coming up on your screen is question number 11. The next question is question number 11. Let me erase this. So let me erase this. Okay. So it's a huge question. A lot of working is involved in this question. Okay, so let's go to the next question. The next question coming up on your screen is question number 11 from the exercise 8B. This is my 5th episode on this question. Here he says the question number 11, and it says the y is equals to ax plus b by the x square has a stationary point. The stationary point is given. The stationary point is given. The stationary point is at 2 comma 12. Okay. Find the value of the a and the b. The a part is find the value, or what is the value of the a, what is the value of the b. Okay, this is the let me read it carefully again, because it's possible that we might make a mistake. So the question number 11 is the curve y is equals to the ax plus b divided by the x square has a stationary point at the 2 comma 12. Okay. Their first question is find the value of the a and the value of the b. The method is same as we did in the question number 10. Okay, so first of all, I'm going to put this point into this curve. In the place of x, I will put 2. In the place of y, I will put 12. Okay, so you will have 12 equals to a into 2 plus b divided by 2 and its square. Okay, so you can see I have substituted the 2 and 12 in x and y, and then so this will be equals to the 12 equals to 2a plus b by 4. So multiply everybody with the 4, you will get 48 equals to 8a plus b. So 8a plus b equals to 48. This is my first equation. So in the A and B, we have found our first equation. You can see 48, it is 8A plus B equals to 48. Okay. So this is my first equation in A and B. Then what I will do, I will find the derivative because I know the stationary point. So what I will do, I will find out the derivative. So I know that the dy by the y is equals to ax plus b divided by the, bring that x here upstairs. So b into the x raised to power minus 2. Okay. So this is my expression. So I'm going to derivate it. So it will be the dy by the dx equals to a plus into minus 2 into the b into the power decreased minus 3 into 1. So my dy by the dx will be equals to a minus 2b divided by the x cube. Okay. So this is the expression for the derivative in terms of A and B. And now what I'm going to do is I'm going to find out the at the stationary point at A at x equals to 2, which is the stationary point x, the value of the dy will dx will become 0. So a minus 2b divided by the 2 raised to power 3 will be equal to 0. You see, we know that the stationary point is at 2, 12. So the value of the dy by the dx at x equals to 2 will be 0 because it's a stationary point. The dy by dx will be 0. So you will have a minus 2b divided by the 8 equals to 0. So you will have a minus b 0. So 4a minus b is equal to 0. So this is my second equation. Now you see we have two equations in A and B. One is 8a plus b equals to 48. The other one is 4a minus b equals to 0. So what we do, we will simply add them. So you will have 8a plus b plus 4a plus b, sorry, it's minus b equals to 48 plus 0. So I have added the first equation and the second equation. I am adding them horizontally. So b and b will be gone. So you will have 12a equals to 48. So the a will be equals to 48 divided by the 12, and that will be 4. So now I got the value of the a, that is 4. I can find the value of the b. Okay, the value of the b will be 4 into 4 minus b equal to 0. So minus b will be equal to minus 16. So the b will be equal to the 16. So I know the value of the a. I now know the value of the b. The a, according to my calculation, is 4 and the b is 16. I don't know. Let's check. Question number 11, sir, of this exercise. A is equals to 4, B is equals to 16. So our answer is right. So this is the A part of that question. You can see we have found the value of the A and we have found the value of the B. So then that is the A part. Now in the B part, he says, determine the nature of the stationary point 2, 12. Okay, so this is the B part, sir. We have to find out the nature of the, this is the B part. Now I'm going to attempt. The B part is find the nature of this point. Okay, so now I know the dy by the dx. Dy by the dx is equals to, that is a is 4, and then you have minus 2b, b value is 16, divided by the x and its cube. Okay, so you can see dy by dx expression I have written. I have that expression involves the value of the you know, the a and the b, I have put those values there. In the place of a, I put 4. In the place of b, I have put 16. That's the expression for the first derivative. And now let me work on it. Dy by the dx will be equals to dy by the dx will be equals to 4 minus 32 by x cube. So dy by the dx will be equals to 4 minus 32 into the x raised to power minus 3. This is the expression for the dy by the dx. Now I will find the second derivative. For this, the second derivative will be d square y by the dx square, and that will be equal to 4 minus 32 into minus 3 into the x raised to power minus 4. So d square y by the dx square will be equals to 4 plus 3 to the 6, 3 is the 9 divided by the x raised to power 4. So this is the expression for my second derivative. So once I know the expression for my second derivative, so even you see, I am, yes, ask your question. Just write your question here. Okay. So I will read that question. Okay, so now I know the expression for the second derivative. Now what we will do, I will put that x equals to 2 in the second derivative to find out the nature of this point, whether this point is a maximum point or a minimum point. So in this, at x equals to 2, I am going to find out at x is equals to 2. So my d square y by the dx square will be equals to, this is 4 plus 96 divided by the 2 and it's raised to power 4. So my d square y by the dx square will be equals to, let me use my calculator, and it will be a positive value without any doubt. 4 plus 96 divided by 2 raised to power 4, and that is equals to 10. So the second derivative's value is 10. I have used calculator, and you know this is a positive value, so that means that this point 2 comma 12 is a minimum point, because the, you know why I'm saying it's minimum point, because the value of the second derivative is negative. If the value of the second derivative is negative, that point is sorry, the value of the second derivative is positive. That's why it's a minimum point. Okay, so so let's start. This was the B part, and we have found that this is the minimum point. Let me check the answer, sir. In your course book, the answer says question number 1, B part, minimum point. So you see our answer is right. This is how you do the B part of question number 11. Then we have question number 11. It's C part. He says find the range of values of x for which the ax plus b by x square is increasing. Okay, so they want this function to be increasing. For a function to be increasing, the dy by dx value should be positive. You know, we have, this is the C part, and he says that the we know the expression for the dy by the dx. Dy by the dx is equals to, I have found somewhere, yes, this is the expression. That is 4 minus 32 by the x. This is the x cube. Okay. So this is the minimum point, and so here we have, he want me to find out Find the range of values of the x for which the ax by b divided by the x square, which is that function, and is okay. So the dy by dx will be, he says that the function should be decreasing. The dy by dx value should be negative. Then the function is, sorry, he said, I look at the wrong part. Is the C part of the question. Find the range of values of the x for which the ax plus b by x square is increasing. So we are basically interested in finding the increasing. Increasing. The function is increasing. Okay. So we have to find out. Okay. So the dy by dx is it's a cubic. So the stationary point is at 2. Okay. And so let me, there can be 2-3 methods. So we have to plot a graph actually for this. I am going to plot a graph and then we will decide on it. Okay. So on my calculator, I'm going to look for that. Okay. I don't have that thing. So let me draw the graph. So let me find out x dy by the dx values. Here we go. So my turning point is at -2. Okay. So I can take -3, -2, -1, 0, and 1, and 2, and 3, and 4. This was my turning point. Okay, at 2. So let me plot these points and find the values of the x. So this is 4 minus 32 divided by the bracket minus 3 bracket close raised to power 3. Okay, raised to power 3. Okay, so my answer will be 5.18. It will be 5.18. 5.18. Okay. So when I will put 4 minus 32 divided by bracket start minus 2 bracket close raised to power 3 equals to 8. This is 8. Okay. And then I will put -1. In this calculator, I don't have that option. Otherwise, we can do it directly. The table can be made directly. Unfortunately, I don't have that calculator right now with me. So it will be 36. Okay. And then you have at 0. At 0, it will be not defined. It will be kind of infinite. Okay. And at 1, it will be 4 minus 32 divided by 1 cube, and it will be -28. Okay. And then at 2, 4 minus 32 divided by 2 cube, 2 and its cube, it will be 0. Okay. So at 3, what will happen? 4 minus 32 divided by 3 and its cube, and it will be 2.8. Okay. 0.8. And at 4 minus 32 divided by 4 raised to power 3, and that will be 3.5. So 3.5. So I can check the value at the 0.5 as well. Okay, let me check the value at the 0.5. Okay, so at the 0.5, 4 minus 32 divided by 0.5 raised to power 3 equals to, that is, -252. So basically the graph is going to be something like this. This is -1, -2, and then -3. The graph is something like this. Okay, this is 1, 2, 3. This is 0.5. Okay, at 0 it's infinite. So at -2 it is, let's say, suppose this is 5, 10, -5, -10, -15, -20, -25. Here you will have 5, here you will have 10, here you will have 15, here you will have, suppose, 20, here you will have 25, here you will have 28. Okay, so not 28, 30. Sorry. Okay, at -3 it is 5 point something. Okay, so this is here. At 2 it is 8, so something is here. At 3 it's -1 is 36. 36 will be here somewhere. So this graph will go like this. Okay, and at 0 the graph is infinite. Okay, at 1 you will have -28 at 0 point. So from here the graph will come at -28. Where is -28? It's going to be here somewhere. Okay, and here it will be here. So this is infinite. So this graph is coming. At 2 you have 0. So this graph is coming like this. And at 3 it is 2 point. At 3 it is 2.8. 2.8 will be here somewhere. At 2 it is 0. And let me check at 3 again. So that will be 4 minus, okay, minus 2.8. Okay. So 32 divided by the, okay. So their question was that where your dy find a range of values of the x for which this is increasing. So when it is increasing, so this is the graph for the dy by dx. When your dy by dx is positive, then your so this goes above this after this. Okay, so the values of the x, when the x is less than 0, you can see the graph, the dy by dx will be positive, and so that will mean increasing. And here the value of the dy by dx, this is the graph on the y-axis dy by dx. Here before the 2, the graph is in the negative portion of the y-axis. So after this, the graph goes into the positive section. Okay, so it goes into this section, the graph is moved like this. Okay, so after the x greater than 2. So x less than, I mean, let me check the answer, sir. The answer is x should be less than 0 and x should be greater than 2. You see, it's decision that on what values of the dy by the, on what values of the x, that graph will be increasing. That graph will be increasing on those values of the x where the dy by the dx value is positive. Okay, so what I did is a quite calculation. What I did, I made a graph, x and dy by dx. I took dy by dx on the y-axis and x on the x-axis. Then I plotted a graph. I know the turning point. The turning point is at the 2, 12, but that is the equation. But I know the turning point is at 2. Okay, so I took some points before the 2, like 1, 0, -1, -2, and -3, and I took some points after it. Okay, so then I plotted the graph, and this is the graph for the dy by dx. And I am looking for that values of the x for which the dy by the dx is in the positive portion. So you can see the graph here. You can see on these values, you can see the dy by dx graph is positive, okay? And up till here, from 0 to 2, the dy by dx graph is in the negative portion. I don't want them. I want that portion where the dy by dx graph is again in the positive portion. So here, after 2, the graph dy by dx value is positive, and here after before 0, the dy by dx graph is showing that the dy by dx value is positive. It's a bit of a question, sir. Its decision is not easy. Maybe there is some other methods as well, but right now this method came into my mind, and I hope that you understand this. This is not that difficult. Just my calculator is not with me. I have today this calculator, and it does not have that table. It does not have that tables option. If you have the calculator, let me show you. This is the calculator I am holding, and it does not have that table option. If you have that table option, so then very easily you see this is not showing any table option. So if it has table options, very easily you can make that table and plot them and decide on what range of values of the x, the value of the dy by dx will be positive. Question number 11, a tough one. Oh, so I think it's enough for today. Today, in one day, we have done 2 live videos, and my first live today was on the exercise 8b, because by chance, by mistake, I have deleted the episode number 1, so I recorded it again, and now that is available. Exercise 8b, episode number 1. I have put that on YouTube. And this is the episode number 5. The main topic of this exercise is the stationary points, and the main is further differentiation. This is pure mathematics 1 AS A levels, mathematics 9709. So if you think that this video is useful for you, please share the link of this video with your friends and with those students who do not have a tutor with them, or whose mathematics is weak and they need to do a lot of questions, and then they are able to grab the concept. For them, this video will be very good. For those students who are very, very brilliant, they don't need to go through the course book. They can prepare their AS mathematics by just working on the topicals. So thank you very much, everyone, for taking out the time. It's a great blessing for me that I can make these videos, which can be helpful to so many students around the globe. So thank you very much once again. Have a good night. God bless you all.